Hello. Welcome back to Leetcode with Benji. Now you may be wondering, since last episode, Ben, has your screen time gone down? And the answer is no. Unfortunately, listen, mate, I've been watching Teenage Ninja Mutant Turtles and Spider-Man, this 1994. Mate, I gotta stop myself. It's actually clinical. Mate, it's bad. It's bad. But we're back on the old Leetcode, and I'm here, Instructor Benjo. So today, what we're looking at? Well, we're looking at this container with most water problem. So what's happening, right? We've got an array, and each each index of the array is the position of our bar. And we can contain water between two of these bars, sort of like in the diagram. So between the two red bars, obviously the maximum amount of water you can hold is the base, so the distance between these two. And in this case, it's just the right index minus the left index. So if you imagine we're looking at this one and this one, this is index 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 0 is 8. So that means our base would be 8 if we were looking at these two. But because we're looking at this one, it's 8 minus 1. So this is 7 times than that minimum of the height of the two bars we're looking at, right? So that's the maximum amount of water we can hold in a container that's using these two bars. And this just happens to be the solution. So let's think about this problem. We're trying to find the most amount of water we can contain using these random bars that we are given. So one way we could do this is we could literally just do this brute force approach. So we take our first bar and we find how much water we can contain between it and the second bar. Then what we do is we look at the first bar and the third bar, then the first and the fourth, and each time we just check, is this greater than the biggest area we've seen so far? And then once we've compared 1 with every single bar, we start at 2 and compare it with every single bar, and then 3 and compare it with every bar. So why don't we just try coding this? So what we want to do is we want to create an integer, and we're going to call this max area. So initially, we want our area to be nothing, right? Because we're never going to have a negative area, but somehow we could have 0. So we want to make sure we start at the lowest area, so we're not making something up. If we have int max area equals 10, and that's actually above any area we can find if we have really, really, really small bars, and they're close together, then we're going to return at the very end int max area, which is 10, but we can't actually hold that much water, so that's just a false result. So we want to start at the lowest area we could possibly have, which is 0. Once we've got that, we just have to create a couple of for loops. So we want to say for int I equals 0, and then I is less than height dot length, right? Because we want to go through our array, and our array just happens to be called height, which is a little confusing, but it's just an array of the heights of the bars at each index in the array. So while it's less than the height.length, we want to increment it by 1. Then we also want to create another for loop inside this with maybe a different pointer, so to speak, and we'll set that equal to 0. Actually, no, we won't. We'll set that to equal I plus 1. Right, so if we're looking at the first bar with everything else, we want to increase j. We want to start j at the second bar. We don't want to start it at I, because if we're doing, right, how much water can we contain between something and itself? Nothing. So we want to start at 1 beyond I, and then loop up until the very end. So we'll also say, well, j is less than height. Also, if you're noticing my noodly fingers, I have tried to swap my keyboard layout, and let me tell you, I did an English essay, and my teammates were not very happy. Mate, the amount of things I spelled, yeah, listen. My L key, no, my L key has become S key, and I had to spell all. It was just a disaster. Right, so now that we've looped through for J, so we've gone through. What are we checking? So we're checking if max area is ever greater than our current max area. So the first time it's 0. So pretty much everything is going to be bigger than 0. But each time we want to set max area to something new if it happens to be bigger than max area. So what we can do is we can actually import math.max. So this is going to take 2 parameters and it's going to return the larger of the 2. So we just have to say we want to take the maximum of our current max area, and now this is where it gets kind of funky. We want to take the minimum of height at I and height at j at j. And once we've got that minimum, we want to actually multiply it by r minus l. Right? Hopefully that's all good. We got our brackets nice and closed. So if this is a bit confusing, what's going on here? Let's start in the middle. So we have our minimum of height at I and height at j. So what is that? What's going on here? So let's say in our example that this is I. So we've started here and we've looked at this one, looked at this one, looked at this one, looked at this one, looked at this, and we've gotten to the end. Well, what is the amount of water we can contain? Well, it's the base times the height, right? That's how we get the area. So the base in this instance, like we saw before, is this index minus this index, right? Which gives us the length of the bottom. So this is index 8 because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is index 8, even though we have 9 items in our array. And then this is index 1. So 8 minus 1 is 7. So we have a base of 7. Then we want to multiply that. Well, hold on. So this base of 7 is this right minus L. So that's how we get right, this index, minus left. Now, sorry, I'm doing right minus left, but that's definitely not right. We want J minus I, because J is always going to be above I, and this is basically the right pointer, right? So this is the right index minus the left index, or sorry, I totally messed that up. J minus I. Sorry if that was confusing. And then we want to multiply that by some height, but we want to multiply it by the minimum of the 2 heights we're looking at. So if we multiplied it by this height, we'd actually start getting water that overflows over this bar. So that doesn't work. We need to multiply the base by the minimum of these 2 heights, right? Because our water doesn't overflow this bar. So we do this height, which is the minimum of height of I and height of j, times j minus I, which is our base. And then if this is bigger than our max, then math.max is going to take this and it's going to set max area to it. Otherwise, if max area is bigger, so say we've got this as our area and then we go to here and compare this one. Well, this one's closer and also a smaller height, so we'll have less water. So we don't want to override the max area. So that's what this math.max is doing. So after this for loop and this other for loop, we're looking at every single bar with every single bar. At the very end, we just want to return max area. Because at the very end, this will be the maximum area we found. So if we run this, you'll see we're accepted, and then if we give it a quick old submit, just like totally ignoring the other solutions, you'll see that we are faster than 16% of Java submissions. But 16%, that's we can do better. Right, this is right corker, but it's not that bad. We can do better. So now let's take a look at some proper explanations, because that was a little quick. Certainly confused me. I probably sounded confused. So say we've got this example. This is our array. Index 0 up to index 7, we've got the heights of the bars. So index 0, we've got our height 1. Index 1, we've got a height 10. And then 3 all the way to our last bar that has a height of 6 at index 7. So what we did previously was we just looked at this bar with this bar, and then this bar with this bar, and then with this bar, and just brute force went in looking at every bar and finding the area each time. And if it was bigger than the biggest area we had seen, well, let's make biggest area equal to what we've just found. But that might not be the most efficient of strategies, right? So that would be O of n squared time. And by that I mean, in the worst case, we, in a way, not exactly, because we don't look at every item for every item, but for each bar, we want to look at every single bar. So we have n times n time, right? So this is the n squared, but that's not desirable. So what we can do is we can find something that runs in linear time. So we just have to scan each bar once. But how do we do that? Well, let's check it. So this is just the same example. What we can do is we can start, and this is where my little cheeky left-right came from. So we start at the left, but we also start at the far right. So we'd create a pointer called L and a pointer called right. And right is just the furthest rightmost index. So in this case, it's 7. And left is totally the opposite, so the far left index. In this case, 0. And it'll always be 0, but the right might vary if we have more elements. So what we want to do is we want to find this area, right? So it's going to be something like this, because the water would overflow if we do anything higher than that. It would overflow over this bar that has height 1. So now if we moved right 1 to the left, our water level, the area of water, would only go down, because our base is going to shrink, right? It's gonna get smaller, and our height is still bound by this small bar, which is only height 1. So if we move left, we're only going to get smaller, so there's no point doing that. And then actually, even in the worst case, say we had a little bar here that was 0.5, we'd actually decrease the amount of water by a lot, not just the base, but also by the height. So we don't want to move the higher of the two bars, right, left and right. What we do want to do is we want to move the smaller of the two. So if left is smaller than right, but not the index, the value at the array, so if 1 is less than 6, which it is in this case, then we actually want to update L to be L plus 1. So we'll update that and move it to the right. So then L comes here. And we're looking at this, and this is the granddaddy of bars, it's height 10. So then we'll set max array if this is greater than what we had seen previously. Then next what we want to do is, notice we have the same kind of situation. If we start moving this one on the right over and over and over and over, we're never going to get something larger than this, right? The only way we could get something larger is if we move the smaller of the two bars. So let's move this one to up to here and then up to here. And notice this is actually probably going to be the greatest area. But that's the idea. So the idea is, let's look at the left, look at the right, and only move in one of the bars if it's smaller than the other. So move the smaller of the two in. So I've got this random slate here, but hopefully that makes sense. So start at the left, start at the right, and then whichever one's smaller, move it in one. All right? And then at the very end, we will return the max area that we found. And luckily, we don't need to return the index of which bars create the biggest area, so we don't need to keep track of that. So we literally can just go through, even if we find it right at the beginning. That doesn't matter. So let's check this updated idea. So how does it work? Well, we similarly want a variable called max area, and we want that to be initialized to the smallest area we can find of water, which is 0, because we can't have a negative volume of water. That is, well, I don't know what that is. Impossible. Then we also want an int L. So this is going to be our leftmost index. And then similarly, we want an int R, and this is going to be the height dot length. So the length of our array. But remember, if you saw the problem last time, we don't actually want height. We want height minus 1. Now that's because if our height was length 3, we'd have 0 index, 1, 2 that we could access. So if we did r equals height dot length, we'd actually get 3, all right? Because 0, 1, 2, that's 3 elements. But if we access the third, we're off the diving board, and like this problem is dealing with water, we'd be drowning in it. Right. So next up, what are we doing? Well, we got a while loop, right? Because we want to make sure that left and right have not crossed each other. As soon as that happens, we're starting to look at elements that we've already looked at, and that is just a total waste of time. So while left is less than r, what we want to do is we want to set max area to equal. Now this is very similar to what we were doing previously. So if we want to find the maximum of the current max area, sorry, max area, not area max, and the minimum math.min of the height at I, but not I this time, so it's a bit confusing, the height at L, and also, let's write that correctly, and height at R. And then what we want to do is we want to multiply all of that by R minus L, so this is our base, right? But then, this is the additional check we need so that we're not checking for every element, is we want to say if the height at left, right, that's less than the height at right, then what do we want to do? Well, height at left is less than the height at right, so let's move the left up 1. So we'll just do L++, simple as that. So our else case takes care of the fact that left and right might be equal, and if they're equal, doesn't matter which one we move inwards. So in every other case, if height at L is not strictly less than height at R, then let's move R to the right. So we just do R++. And then at the very end, we exit our while loop, and we just return max area. So this, just like the other way of solving this problem. Oh, sorry, I did R++. We want to move right 1 to the left, so we want to actually subtract 1. We don't want to add 1, otherwise we're going way off our array, off the diving board, and drowning. So if we run this boy, you'll see that I've got this error with height, and some other little cheeky bracket error. But you know what? That's the keyboard. That's the keyboard, isn't it? What's happened there then? Beautiful. Beautiful, lads. Right, run that boy. Oh, wait, I've forgotten height or length. Oh, it's just a shambles. Oh, wait, somehow I've deleted. Oh, no, I've done that weird insert thing, haven't I? Okay, there we go. Right, run that boy. And there we go. We're accepted, and we'll do a quick submit. So last time, I think we were faster than 16% of submissions. This time, we're faster than 94.45. That means we are in the top 6% of mines. Memory usage, wouldn't worry about that one. It's all about speed. And so there we go. Happy days. We got Leetcode number 11 container with the most water sorted. It's easy. It's easy for us. Hopefully that did help. This was a bit of a waffly one, so I apologize for that. That's yeah, it's just one of them, isn't it? But hopefully that did help. If there's anything that I can clear up, leave a comment. Any other problems you need a little titillation with, let me know. Anyway, cheers and bye-bye.